is easy, okay? Two sets are equal. If they have the exact same elements, okay? Two sets are equal if they have exactly the same elements. Make sense? Okay. All right. Well, there are a couple of little ramifications there that you might not have thought about. Two sets are equal if they have exactly the same elements. Or in other words, this set here is equal to this set. Say we got A equal B. Well, for that to happen, all the elements here have to be elements of B, and all the elements of B have to be elements of A. So that's kind of a check there. That's all you're doing. That's the only way you can have equality. One equals the other. Okay? Well, let's think about that. Obviously, that's a no-brainer. Okay? ABC equals ABC. That set equals true enough. Okay? Well, what about D, E, F, G? Switch it up a little bit. D, E, F, G, does that equal G, F, D, E? Does, doesn't it? This is equal. Even though they're listed in a different order, why are these equal? Well, all the elements here are elements over there, right? All the elements here are over here and vice versa. This is equal. They have exactly the same elements. What does this mean? In sets, does the order really matter? No. In sets, the order doesn't matter. Or another way to put that, just rearranging the elements doesn't change the set. Just rearranging the elements doesn't change anything. It doesn't change the set. Okay? So if I say, back on those listing, when I was listing all those subsets, that's the reason I didn't list like MK, I had MK. Well, I didn't go and do KP, KM again, because those are exactly the same. Those two sets are the same. They're equal. So just rearranging the elements doesn't change your setup. Okay? All right? To get not equal, how do I get something not equal? Well, I have to have a different element somewhere along the way. Like if I had A, B, C, is that equal to B, C, D? Same size. They're not equal, are they? Yeah. That one's not equal because you've got different elements. So that's how you get a set not to be equal. Now here's another little issue. Rearranging doesn't change, but what about this? ABC, does that equal AA, BB, B, C, 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 C? Those equal? Well, let's talk about it. They have the exact, what are the elements here? A, B, and C. What are the elements over here? A, B, and C. Do they have the same elements? Yes, they do. These are equal. This set is equal to this set. So what's the point of this? Repetitions don't matter either. In sets, repetitions do not matter. Or another way to put it, you're wasting your energy or your pencil lead or your ink by writing an element more than once. Because once you have the element, duplications don't matter. Okay? Repetitions do not matter in sets. So if you got the element once, does you no good to write it again because it's the same set. No matter if you have that element once, you have it 3 times, 4 times, once is just as good. Okay? So repetitions don't count. In other words, repeating an element doesn't change the set. Okay? Repeating an element doesn't change the set. You have to have a new element to change the set. Repeating element doesn't change it. Okay? All right. So that's a couple of things on equality I needed to mention. And, in certain things, rearranging does change. Like if phone numbers, if you rearrange your phone number, does that change it? Yes. So there are times when changing the order does change, but not in sets. Sets of elements, rearranging doesn't change it. So just want to point that out. Think right.